Hello friends, welcome again. Today we'll be solving a question related to electrical machine. And the question is a 6 pole 12 kilowatt 240 volts DC machine is wave connected. If this machine is now lab connected and other things are same, find its voltage and the current rating. Okay. So how to proceed for these kinds of question? So it is wave connected. Okay. First it is wave connected. So for wave, okay, how you can remember is in wave there is a. So a is equal to 2. 2 means the number of parallel paths. Okay. So there are two parallel paths in wave. Okay. And the other thing that you need to remember is in lab a equals to p means the number of parallel paths is equal to the number of poles in the machine. Okay, so these two things if you remember, then it is very easy to solve. So let us proceed and solve this question now. So what we are going to do is we are going to first find the current rating. Okay, so the current rating will be power equals to V into I, so voltage into current. Okay, so this is in kilowatt, so in watts it is 12 into 10 power 3 over 240, okay, is equal to I. Okay, so when you calculate this current it comes out to be 50 amps. Okay, so this is for wave connection. Okay, so these calculations are for wave connections. Okay, so for wave you are getting 50 amps as the current. Okay, so this 50 amps, how you can visualize this is, see there is 50 amps. Okay, and the voltage is 24 240 volts, and what is happening is this 50 amps, because there are two parallel paths, so it is dividing into 25 and 25 amps. Okay, and again here you can see it is 50 amps. Here this dot is shown because we don't know the number of coils, hence you can see that the 50 amps is getting divided into two equal parts. Okay, now what you can understand from here is, because the current is 25 amps is flowing in each parallel path, hence the coil rating or the conductor rating has to be 25 amps. Okay, so conductor rating is equal to 25 amps. Okay, conductor current rating equals to 25 amps. Okay, now since conductor current rating is 25 amps, so when we go for lab, okay, for lab connection, okay, so if we go for lab connection, we have six parallel paths because p equals to 6 here. So these are the six parallel paths shown, and each conductor has 25 amps current carrying capacity. So each conductor will have 25 current carrying capacity. Okay, so 25 into 6, so current rating will be 25 into 6. Okay, and this comes out to be 150 amps. Okay, so this is the current rating of the machine. Okay, so once you have got the current rating, you need just voltage rating. Now you can see here that two parallel paths, okay, when they are in parallel, 240 volts is the voltage rating. Okay, so if there was only one parallel path, or there was only one path, you can say, if there was only one path, then the voltage rating would have been for one path. Okay, voltage rating is equal to 240 into 2, because the two paths will be identical here. So okay, so it is 480 volts. Okay, so now you have got the voltage rating and the current rating. Okay, so now this voltage rating has, now we have six parallel paths in lab. So for lab voltage rating is equal to 480 over number of parallel paths. Okay, a, so 480 by 6, so this is 80 volts. Okay, so you can say that now the voltage rating is 80 volts. Okay, so this is what is shown here. Okay, each parallel path has 25 amps and the voltage rating is 80 volts. Now if we calculate the power rating, it is simply the voltage rating into the current rating. Okay, so these two if we multiply, so the power rating now if I calculate is, power rating is equal to this voltage rating which is 80, okay, into 150. Okay, so this is our power rating. Okay, if you calculate this, it will come out to be 120. Okay, so it is 12 kilowatt, okay, power rating that you will get, okay, which is same. Now you can see here that we have got the voltage rating as 80 volts and the current rating as 150 amps. Okay, so this matches with option A. Okay, so option A is the correct answer. Okay, so this is how you need to proceed for the problems involving a lap or a wave winding. Okay, so thanks for watching.